Today I'm going to be solving one of the hardest maths problems from this year's JEE Advanced paper. Let's dive straight into it. This video is sponsored by Brilliant. Okay, so this is the question here. It's question number 6, and I believe this is from paper 2. I basically asked people who'd sat the JEE Advanced what the toughest maths problem was. This came up, and I actually saw another YouTube video on someone saying that it was one of the toughest. So that's why I'm doing it today. But if you have any other questions from the exam that you think I should look at, because they might be harder than this, then let me know in the comments. So the question itself says, let S denote the locus of the midpoints of those chords of the parabola y squared equals x, such that the area of the region enclosed between the parabola and the chord is 4/3. And then it says, let R denote the region lying in the first quadrant enclosed by the parabola y squared equals x, the curve S and the lines x equals 1 and x equals 4. Which of the following statements are true? And so we have, okay, well, which of these belong in S, and then the area. So I guess we can deduce A or B from this first part of the question. So we're going to focus on that initially. So, like with any maths problem, I love to do a little drawing. So we have a parabola, so let's draw that. Let's do it like this. And we have a parabola like this. And I'll just move that over. So we know that we have y squared. This is y squared equals x. And that's why the parabola is on its side, because it's y squared equals x. Now we're told that there is a chord of the parabola, and it's essentially across this, so we can draw the chord. So it's probably going to look something similar to this, and I'm going to just denote the points at which this crosses the parabola. We're going to have this as x1, y1, and this as x2, y2. Okay, and then we'll have a midpoint here somewhere, so I'm going to let the midpoint be P. And I'm going to call that xm, ym for the midpoint of this chord. So we'll call that A, the point for x1, y1, and we'll call this B for x2, y2. Okay, so we know that we have, well, AB, that's the chord. We know that P of xm, ym, well, that's the midpoint of AB. And I guess we know as well, I'm just going to put these in bullet points, we know as well that we have AP, well that's going to equal PB, because we know it's the midpoint between this chord here. Now again, I'm going through this slowly so you can understand the problem, but in the exam, I think, correct me if I'm wrong, but I swear you have about 2 minutes per question for the JEE Advanced. So already I've gone through this in 2 minutes. So I'm going to go through the video slowly so you understand, especially those that might not need to do the time pressure. But be aware in the exam, you have very little time to do this. So let's have a look then. So we have a chord, and you might remember that, and I'll write it here, that the equation of a chord on a parabola y squared equals 4ax with the midpoint xm, ym, well, we have this expression for it. We have y multiplied by ym, which is the midpoint, minus 2a, all multiplied by x plus xm, equals ym squared minus 4a xm. So this is the equation of a chord on a parabola for y squared equals 4ax and this midpoint. Okay, well, we know that for us, our parabola is y squared equals x. So a here is going to equal a quarter. So with a equals a quarter, this becomes, well, we have y multiplied by ym minus, so this would be a half, x plus x equals y m squared minus x m. Okay. Now we can deduce this further, and what we can do is we can get a equation for x. Now the end goal of this is we're going to obviously want to calculate an area, and we're going to be wanting to calculate the area of the region enclosed between the parabola and this chord. So we're kind of wanting this area in here. So obviously if we're going to be integrating, then we want the expression in terms of x. And that's because we're going to be obviously be integrating between the x values and in terms of x rather than y. So we can rearrange this in terms of x. And we get x equals 2 multiplied by ym multiplied by y plus xm minus 2ym squared. Fantastic. So we now have this equation for x. Now we're going to want to calculate the area. So I'm just going to copy this and move it down just so we know what we're dealing with. So we're going to want this area in here. This orange kind of shaded area. Now we can, just for illustrative purposes, put on here, well, we know that this is going to be the kind of area of integration that we're wanting. It's kind of over this area. That was a terribly drawn straight line, so I'm just going to do that again. So, and of course we know that here x equals 0, so that's going to be y1, and that's going to be y2. Okay, so, and I'm going to draw this out just for people that might not understand this straight away, but we want to calculate this orange area. But what we have is we have the equation of the chord, and if we were to integrate between y1 and y2, then we'd end up with this entire area in here. But from there, we then need to subtract the area under the parabola, which would be this area in here. So we can see that the area here would, well, it would be the integral between y1 and y2, which would be, we'd have y1 here and y2 here. That's the area, that's the region that we're interested in. And then it's going to be, well, it's going to be the x, equation for x of the chord in terms of y, because that would give us this area in here, all underneath the chord. And then we would subtract the x value of the parabola in terms of y. And that's because that would be all of this area under here, like I mentioned. And so then what you'd end up with is this area, which is exactly what we want. Okay, so we can substitute things in here. So this is just going to be, well, we have the integrals area. Now we know this equals 4/3, but we'll substitute that in a moment. So we'd have the integral y1, y2 of x chord, which we know is this expression here. So we'd have 2y plus x minus 2y squared minus x of the parabola. Well, we know that the parabola itself is x equals y squared, so that would just be minus y squared. And we'd have all of that dy. Amazing. Now if we integrate this, well, we would get the area would be between, so we'd have, let's integrate each of these. So we'd have 2y, well, we wouldn't have 2, we'd have y squared, and that would multiply by half. So we'd have ym multiplied by y squared, minus, we have two constants here. So we have minus 2ym squared plus, well, actually that would be a minus, because a minus and a minus is a plus. So minus xm multiplied by y, and then if we integrate y squared minus y squared, we'd get a third y cubed, and this would be between y1 and y2. Now I'm just going to call this equation star there. So far, while solving this problem, we've needed to use integration, and as you'll see later, we're going to need to use some additional areas of calculus as well. Now, if you find calculus almost as cool as I do, then you'll love Brilliant's newly updated calculus course. It builds your mathematical intuition while making you a better thinker and problem solver, which is what Brilliant is all about. Brilliant has thousands of visual, interactive lessons in maths, science, programming, data analytics, and even AI. What I love so much about Brilliant is the ability to build a very powerful daily learning habit. You can pick up your phone or device and learn little by little each day. To learn for free on Brilliant, go to brilliant.org/Ellie Slightome, scan the QR code on screen, or click on the link in the description. Brilliant is also giving you, my viewers, 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thank you so much to Brilliant for allowing me to make really cool videos like these. Now let's get back to the maths. So if we substitute y1 and y2 in here, well, this is just going to become, we'd have ym of y1 squared minus y2 squared minus 2ym squared minus xm of y1 minus y2 minus a third y1 cubed minus y2 cubed. Okay, and that is the area that we have here. Now, we kind of need to essentially reduce this in terms of some other values, and then we can use that to evaluate the expression and get a new equation for, what do we want the equation for? We'd want it for the curve S. Okay, so we can now use some things. Okay, so we know that we have, let's put note, we have A, which is x1, y1, and B, which is x2, y2. But we also know that x is y squared. So we can rewrite this as, well, this would just be x1 squared, and B would be x2 squared, sorry. And that's just using the fact that we have a parabola here. Now, we can also say, well, we have the midpoint here, P, so we can write some expressions in terms of P, because we know that, well, x1 plus x2 divided by 2, well, that would give us xm. So, I'm going to write it on here. Also, we can say that x1 plus x2 divided by 2, well, that's xm. And similarly, we can say y1 plus y2 divided by 2 gives you ym, which gives you x1 plus x2 equals 2xm, and y1 plus y2 is 2ym. Now recall what I just said here. We know that, well, x is y squared, so this can also become y1 squared plus y2 squared equals 2xm. Now I'm going to call this equation 1 and this equation 2 because we're going to use it and we're going to manipulate it to get some expressions for y1 minus y2 and these expressions here. Okay, so what we're going to do is we're going to say, well, let's take 2, our equation number 2, which is this one here, and we're going to square it. Okay, well, that will give us y1 squared plus y2 squared plus 2y1 y2 equals 2y, well, that would actually be 4ym squared. Okay. So from this, we can say, well, then 2y1 y2, this is going to equal, well, we'd have 4ym squared minus y1 squared minus y2 squared. But what is minus y1 squared minus y2 squared? Well, that just equals minus 2xm. So from this, we can say, well, actually, we know that 2y1 y2 is 4 multiplied by ym squared minus 2xm. And this is going to be a really important piece of information that we're going to use. And I'll show you why that is now. So I'm going to just call that equation number 3 because that's equally as important. Now, what you might notice is, well, we're going to need to find some sort of expression for these y1, y1 minus y2. So let's try with y1 minus y2, and then we'll move on to these y1 squared and y1 cubed and such. So now what we can say is, well, y1 minus y2, well, this is nothing other than the square root of y1 minus y2 squared. It's a really nice little trick that we do there. And if we expand this out, what we would get is, well, we'd have y1 squared plus y2 squared minus 2y1 y2, all square root. Now, I realise you're probably getting to the point in the video where you're thinking there's actually a quicker way that we can do this, and I'll show you exactly how we'll do that later. But for the brute force method, I thought this was a nice way of just showing you exactly how we set up the problem and solve things, because later on we can just use a little hint to kind of simplify this a little bit further, so we don't have to do one of these long expressions here. But we know from this, well, we know that y1 plus y2, well, y1 squared plus y2 squared is none other than 2xm, and what did we just calculate? Calculated 2y1 y2. So this is going to be 2xm minus, so that's going to be 2xm, just to confirm, yep, minus, well, we have 4ym squared minus 2xm. This is all going to be square rooted. Now we can simplify this because we have 2xm minus minus, which is a plus 2xm, so we would have, this is 4xm minus 4ym squared, all square rooted. And this is none other than, well, we'll take the factor of 4 out. This is 2 square root of xm minus ym squared. Okay, so that's great. We have the first term of y1 minus y2, which we can eventually substitute into here. And we have it in terms of xm and ym, which is exactly what we want, because we have ym and xm in here. And then we can eventually say, well, area is 4 over 3 equals this. This will reduce, which is what we'll see in a moment, and then we can deduce something from that. But we've got y1 minus y2, but what I would like now is to work on this term. So we're going to do, and I'll explain why I'm doing this term first in just a moment. So we're going to do y1 cubed minus y2 cubed. So let's go back to that. Now, while I'm doing this, I find it incredible that, this is literally supposed to be a very quick question in a JEE Advanced. And I would actually love to know how many people did this correctly. I was watching a video on some people doing the problem themselves who are tutors for the JEE Advanced, and they said this would be a problem that you would probably come back to at the end of the exam and try and attempt it, because it's quite a tricky, the problem itself isn't too tricky, it's just incredibly long and a lot of, no room for error really, you need to be consistent with it. But let's go back to this. So y1 minus y2 cubed. Now you might notice that, well, this is actually y1 minus y2 all multiplied by y1 squared plus y2 squared plus y1 y2. And you can calculate this yourself if you do the, y1 times y1 squared would give you the cubed. Similarly for this, I'd give you the negative. And then if you did, well, we'd have y1 times y2 squared multiplied by y1 times y2 squared, and they would negative and they would subtract from each other, so we'd end up with this expression, and you'd do the same again. So yeah, you might notice that we can rewrite it in this term, in this expression here. Well, we know what y1 minus y2 is, so this is going to be none other than 2 of the square root of xm minus ym squared. And again, we know what this is because we calculated it. That will be 2xm plus, now we have to have a half in here because y1, y2, we calculated it in terms of 2y1, y2, so it's just a half of this, so it would be 2ym squared minus xm. So we'd have 2ym squared, I just did that, let me just rub this out because it would be what I just said, which would be 2ym squared minus xm. And we can simplify this to give us, well, we would have, what would we have? We'd have 2ym squared. In fact, actually, I'm going to write the xm first, and I'll explain why in a moment. Xm plus 2ym squared. Okay, so we now have a term for y1 squared, y1 cubed minus y2 cubed. All that's left is to do the y1 squared minus, there's so many y1s and 1s and 2s, minus y2 squared in here. Well, this is none other than this lovely expression here. And we know what this is. Well, y1 plus y2, that's just 2ym, and y1 minus y2, we've just calculated that. It's 2 square root of xm minus ym squared, and this would give you 4ym over xm minus ym all squared. And now what that means is we can substitute each of these back into the expression, whereas the expression, it's here, back into there. So, in fact, I'll call that star instead, and we'll substitute in. So I'll say, and I'll probably, yeah, I'll do it here, sub into star. So what do we get? Well, we get the area is going to be 4 over 3, because we're told that in the question. Area is 4 over 3. This is going to equal, well, we'll have 4ym squared over xm minus ym squared, because we have ym multiplied by this term, which was essentially just this multiplied by ym, which is why we get this here. And then we'd have minus, now we'd have the factor out front, which was 2ym squared minus xm multiplied by this, which we've calculated, which would be 2 square root of xm minus ym squared. And then we would essentially just take this entire expression here, just multiplied by a third. So here we'd have minus, I'm going to try to fit it all on, minus 2 over 3 xm minus ym squared, all multiplied by xm plus 2ym squared. Yep. Okay. Now let's look at this and see if anything cancels. So we have 4ym squared, we have this term here multiplied by the square root. Well, we also have that here, so those would cancel. So we'd have this would cancel with this, and then we'd be left with, we'd have, let's pull out the 2 xm minus ym squared. We would have, what would we have here? We'd have xm, which we see here. So this is again 4 over 3, equals this. We have the xm, then we would have the minus 2 over 3 xm minus 4 over 3 ym squared. Okay. Now we can take out a factor of a third in here. So that would become, well, we'd have 2 all of this again. And we would just have 3xm minus 2xm minus 2ym squared, I believe. Let me just double check. Just made a little mistake there, so let me just rewind. That should be a 1, that should be a 2. And that's just because I already took out the factor of 2 here, which is there. So that should actually be, that should be minus xm, and that should be minus 2ym squared, all over 3. Again, we can make this nicer by 3xm minus xm is literally just 2xm, so that would become 2xm. And we can take out the factor of 2, so if we take out the factor of 2 here, which is what I was originally trying to do, we'd have 4 here. But then this is literally just, well, we have 4 over 3. We have xm minus ym squared. We obviously have a half from here, but this now has turned into a power of 1. So we have a half plus 1, so that gives you 3 over 2. Now we can equate this by simply, let's have a look, we have 4 over 3 on either side here. We can make this equal, so you'd end up with 4 over 3 equals 4 over 3 of xm minus ym squared 3 over 2, which from this we can then deduce, well, that must mean that x minus y squared must equal 1, and that's using this in here. Fantastic. So we've now used this to deduce the curve S, which is what we have here. So the curve S, which is fantastic. And yeah, it took a lot of getting there, but we eventually got there. So let's now use this equation for, in fact, we can rewrite it. It's the same as y squared equals 1 minus x. No, it doesn't. It's y squared equals x minus 1. So let's have a look then. So we can rewrite that and say that's the same as y squared equals x minus 1. Okay. So we have this new equation here, which is fantastic. And if we draw that, it might help us kind of see things a bit clearer. So we have the original parabola, which is here, which is there. And that's x equals y squared. But now we have this new parabola, which is going to look like this. If I can draw it. It's not the best, not the best drawing, but we're going with it. Not quite to scale, but it's still there. And actually, I'll colour it in orange. And that's x. That's x minus 1 equals y squared. And the question says, well, let R denote the region lying in the first quadrant enclosed by the parabola y squared, the curve S, and the lines x equals 1 and x equals 4. So we need to add in the x equals 1 and x equals 4 into our diagram, and we need to ensure that it's just in the first quadrant that we're looking at for the area, for the region, should we say. So this might need a little extending to it. Okay, so we now have x equals 1, which is going to be here. Move that over slightly. So that's x equals 1. We then obviously have an x equals 4. That's x equals 4. And we want the first quadrant. So the region that we're interested in is this region in here. And so we can do another integral. We can do the integral of both of these equations here between these limits, and find exactly what this region is, and that will hopefully then help us go back to the question and figure out exactly what statements were true. So all we need to do is we're going to do the first quadrant. So area is going to be, well, we're going to have the integral between 4 and 1 of the square root of x minus the square root of x minus 1, which again is just this minus this here between 4 and 1. Amazing. So let's calculate this. Well, this is none other than 2 over 3 of x to the power 3 over 2 minus 2 over 3 of x minus 1, 3 over 2 between 4 and 1. Take out the factor of 2 over 3, and then we'd have, so what would we have? We'd have 4 to the power 3 over 2, that's 8. Then we'd have x minus 1, so 3 to the power 3 over 2, well that's 3 root 3. And then we'd have the 1 in here. Well, obviously the 1 minus 1 would equal 0, but the 2 over 3 multiplied by x to the power 3 over 2, that's 1. So we'd have a minus 1 in here. And this equals 14 over 3 minus 2 root 3. And that's the answer to this region that we have here. So let's look back at the question. Was that in the answer? It is. It's right there. Amazing. So we calculated the area of R, and it is indeed 14 over 3 minus 2 root 3. So we can say a tick to that. And by observation as well, we can also say that the answer is A, because that belongs in the curve S, which is what we have also calculated here as well, within this curve. So the answers, so therefore A and C are true. Amazing. So that is the way that you solve, or one way that you can solve this problem. Now there is actually a really nice trick that you can do, which I'll show you, in order to basically simplify things a little bit further, but there is still a lot of extra work that goes into this. But all in all, I do think it's a really, really nice problem. So the trick that you're going to do, the little trick that's kind of helpful, is if we just take a look back at our diagram in here, and I'm going to copy it for purposes that I don't want to mess up the original solution. But what we can find is, well, what we did before is we calculated the equation of the chord. So we calculated kind of this equation in here, so that then we could calculate this area. But what you can also do is just notice that this area in here, well, this is just a trapezium. And so we can use what we know about what we're given in the question to calculate that area. So I'm going to just draw some lines on here and say, kind of, it's a trapezium. Okay. So, and what do we know what the area is? Well, the area of a trapezium, that's just a half times A plus B multiplied by the height. And for us, A plus B, well, A plus B is going to be x1 plus y2. So that would be x1 plus x2, sorry, should I say, multiplied by the height, which is just, we knew this was y1, this was y2. So all that is y1 minus y2. Now remember, we know that x1 is y1 squared, x2 is y2 squared, and so the area there of the trapezium equates to this. And then all we need to do from that is minus the area from the parabola itself, so everything underneath here. And so the total area is just going to equal a half of y1 squared plus y2 squared multiplied by y1 minus y2 minus the integral of the parabola, which is a third y1 cubed minus y2 cubed. And then, so all you would really need to do in this instance is calculate y1 minus y2 and y1 cubed minus y2 cubed. So you would still need to calculate this section here, and you still need to calculate this section here. But you wouldn't need to calculate this because we didn't need to substitute that in. That's not in our new area equation. So that would make things a lot easier because you would just need to calculate these two things here and then substitute it back in. The good thing about the original solution is this didn't actually take too long to calculate, but you did then have to substitute it back in and do this extra step of realising that actually these two things cancel and, you know, continue as we did there. But with this new method, you don't need to calculate that, you just calculate these two expressions here, substitute it back in, and what you find is you get the exact same expression out, and then you continue as before to get the solution. So that was a nice trick that you could spot there. I think the big issue with this question is the time, and the time that it takes for students in the exam to attempt it. And I think that's why when I was watching that video, somebody said, well, actually, you're probably going to be doing this at the end of the exam, unless there is a really, really nice, simple solution to this, which if there is, let me know in the comments, because I'd love to know, because I've spent a lot of time working through this problem. But yeah, it's incredible that this is in an exam, and in an exam where you have to do it within 2 minutes, I think. It's actually a really beautiful problem, just very, very tricky and perhaps not beautiful when you've got the time pressure added as well. But that was the solution to the problem. I really hope you enjoyed the video. If you did, then please like, subscribe and comment, and I'll see you all in the next one.